This video is part 2 of chapter 25.2 on integration. In my first video, I got through quite a few of the problems, and I'm continuing on the handout. It's actually the back of the handout, problem number 4. And problem 4 lists this. Find the antiderivative, that's the symbol, of 3 minus 8x dx. Remember, we're doing the inverse of differentiation or finding the derivative. So this is a polynomial, so you just treat each one of the terms separately. The 3, when we do integration on the 3, it would become 3x. Because remember, if you took the derivative of that, it would give you the 3. How do we do the negative 8x? Leave the negative 8, take your x, which is to the first power, and add 1. 1 plus 1 equals 2, and divide by your new power of 2. Lastly, don't forget you have a constant of integration that you have to put in every answer, because we don't really know what that constant stands for. This is called the indefinite integral. So we simplify that and we get 3x minus 4x squared plus c. So far, not too bad. Let's try one that looks a little tougher. Problem number 5. Find the antiderivative of the square root of r minus 1 over r to the third dr. Again, we take each problem separately. This one's going to look a little strange as we do it, but hopefully you'll be able to follow. I'm going to first rewrite this as find the antiderivative of r to the 1/2. Remember, this is to the power of 1, and this is to the index 2, so that is 1/2, minus r to the negative 3 dr. Now I can treat each term separately and take the antiderivative. So the first term is going to give me r to the 1/2 plus 1. That would be plus 2/2, which equals 3/2. And then, of course, we have to divide by the 3/2. I'll show you how to work that out in a minute. Minus, in this case, we would have r to the minus 3 plus 1, which is negative 2. So we have to divide by negative 2 and add our constant of integration. If you take the problem up here, how do we get rid of the 3/2 here? One way to do that is to multiply this by the reciprocal, 2/3, and multiply this by the reciprocal, 2/3, because what you do at the bottom, you have to do the denominator, you have to do the numerator to keep the problem the same. That would give us the 1 on the bottom, which is perfect. So we end up with 2/3 r to the 3/2. And over here, what will we have? Well, what's a negative times a negative is a positive. And this would give us r to the negative 2 over 2 plus c. So all I really did was get rid of the 2 double negatives over here. Now, you know that in math you can't leave your negative exponent, so we have to move that r to the negative 2 to the denominator, and then we'll be done. So we have 2/3 r to the 3/2 plus, have to keep a 1 up there because there's nothing else up there, and we're moving this down because it's negative. The 2 stays where it's at. This becomes r squared and plus c. And that is how you integrate that problem. Let's try one more. Actually, number 6, not one more, number 6, which is also on the sheet. And number 6 looks a little different, and you have to look at this one this one can be done, it's kind of strange. We have x squared plus 1 to the 3rd power times 2x dx. when we start getting into these powers, remember how we had the chain rule? When you start getting into problems that have the chain rule, we're going to have to do, you don't have to, but one way to do them is to use what's called a U substitution. And here's how it works. I'm going to let U equal whatever's inside here, x squared plus 1. Now, if that were the case, tell me, just go back to our derivative. What would the derivative of this be? It would be what? 2x dx. Okay, we're going to use this information to rewrite this problem. So I'm going to rewrite this problem as take the antiderivative. Now this x squared plus 1 is u, so I'm going to write u to the third, and then notice the 2x dx is what? du. So all I did was substitute in the u's. Why am I doing that? Because it makes it easier to now take the antiderivative. So we take u to the 3 plus 1, which is 4, and we divide by 4, plus our constant of integration, which means we have u to the 4th over 4 plus c. To finish the problem, you have to substitute what u equals back into this problem. So we would have x squared plus 1 to the 4th over 4 plus c. And that is how you take the antiderivative of a problem that's much more, or a little bit more complex. Okay, now if you look in your book on page 749, there's some problems that you can practice. And I'm going to do a few of them right here with you so that you get the idea and make sure you're getting enough practice finding the antiderivative. So I want to do the first one is number 9, and it says find the antiderivative of x to the 1/2 times x squared minus 5x dx. In this instance, when you see a monomial times a binomial, what we want to do is to distribute before we try to take the antiderivative. So I'm going to distribute this x to the 1/2 to both of these terms. And I would get the antiderivative of x to the, remember what we do with exponents when we multiply, we add them. So I would have 1/2 plus 2 minus 5x to the, this is a 1, remember, 1/2 plus 1 dx. Let's simplify that. That would give us x to the 1/2 plus, I'm going to rewrite that too as the same as 4/2 because I need to have the same bottom number to be able to add these two. And that would give me x to the 5/2. Look that over. Make sure you follow your fractions, basic fractions, minus 5x to the, I have 1/2, and I'm going to change this 1 to be 2/2 because it has to have the same bottom number, which gives me 3/2. So I would have minus 5x to the 3/2. So that's the problem. Now I have it written out, and I can take the antiderivative of this problem by taking the antiderivative of each term. So this one would give me x to the 5/2 plus 2/2, because we're adding 1 when you take the antiderivative, equals 7/2. And then, of course, we have to divide by the 7/2 minus 5x to the 3/2 plus 1, which I'm going to write as 2/2, so they have the same bottom number, which equals 5/2, and then you have to divide by the 5/2, and then don't forget your constant of integration. All right, let's simplify this mess up here. I could take the 7/2 and multiply it by 2/7 and do the same here. I could take this and multiply it by 2/5 and do the same thing here. Multiply it by 2/5. So in the first one, I would have 2x to the 7/2 divided by 7 minus, the 5's cancel, and I would have 2x to the 5/2 plus c. And that, believe it or not, is your answer. Strange as that looks, that is your answer. Okay, I think we have time for one more, and then I'm going to move on to the next section. What I'd like you to try to do is to do some of the odd or some of the even problems on page 748 and 749. If you need additional practice, I want you to try to do 6 through the 26 evens, and I will post answers to them so that you can check them. In the meantime, I have time for, I think, one more problem before the video runs out. So I'm going to look at problem number 21 in your book. Problem 21 says we can take the antiderivative of 2x to the negative 2/3 plus 9 dx. So again, we're going to take the antiderivative of each term. This would give me 2x to the negative 2/3 plus 1, which would be 3/3, because the bottom number is 3. And I would get what here? Negative 2 plus 3 is 1/3. So I've got to divide by 1/3. Excuse me. Plus, I have a constant, so we know the antiderivative would have to be 9x, because when you take the derivative of 9x, you get 9. And don't forget your constant of integration. And we would multiply this by 3/1, and this one by 3/1, which would give us 6x to the 1/3 plus 9x plus c, and that is your answer. Okay, so I'm going to stop this video now because we only have a minute to go, and I'll pick up in a few minutes on another one.